Hey guys, make sure you have the stuff you need for this lesson before you get too far. You're going to need your lesson packet and you're going to need a calculator. So grab those if you don't have them, pause the video, go get those, and then otherwise let's turn to the second lesson, which is on circumference. Have you find that? That's there in your packet. And you should already have an idea about circumference, actually quite a bit. This should be some review, but we're going to go a lot deeper into it from what you've learned in middle school. But keep in mind that circumference is just the same thing as perimeter. We're going to figure out the measurement or the length around a figure like we did with perimeter, only our figure now is a circle. So let's just look at a quick demo to review the idea of circumference. And here on this demo, I've got a circle. Its diameter is given as 4 units. And the red distance around, that red length, that's the circumference of the circle. We're going to unwrap it. So I'm going to roll this circle around the x-axis. And as I do, notice that the red is unwrapping, kind of unraveling as I lay it out until I get to the end of that length, which is about 12.57. Now remember the diameter was 4. So you should have studied how the diameter is related to the circle. How much longer is the circumference than the diameter? So let's just take the diameter and let's fit as many diameters into that as we can. Count them as we go. There's 1. Here's 2. 3 there. And then there's just a little bit more than 3. So if I reset this back to the beginning, I can make a smaller circle. Let me come down to a diameter of 3. Now that makes the circle smaller. That makes the circumference a little shorter. If I unwrap the circumference and lay it out in a straight line, now the circumference is only 9.42. Well, the diameter was smaller, so that makes sense. We got a smaller value. How many diameters can fit in that circumference length? Count them again this time. There's 1. There's 2 and 3 plus those a little bit more. So 3 plus a little bit more, you should recognize that as the number pi. Pi is 3 plus a little bit more of the decimal part. Okay, so we know that the pi is involved in the circumference. And remember, pi is 3.141592, and it keeps going and going. We can remember it's approximately 3.14. As we do our calculations, I'm going to ask that you do not use the 3.14. I want you to use the symbol for pi, and I want you to use it on the calculator. So if you don't know where your pi button is, it's going to be down here. It's right here on the alpha keypad. There it is. You hit that button, and you end up with this little menu, and pi is the first thing. So you just hit enter, and you can get pi in your calculator, which we know is about 3.14, and a little bit more than that. Okay, these formulas should look familiar. In middle school, you probably did a lot of work with this formula, pi times diameter. And that's true formula. We'll use it every so often, but I really want you to set a goal to get used to using this formula more. This one's a very popular formula in the higher math you go. So 2 pi times the radius. Now the radius and the diameter are very related. It's double the radius gives you the diameter. So it's the same formula. It just uses the radius instead of the diameter. Please make sure you try to use that one more often than not. Okay, so let's tackle exercise 1. And I should tell you, exercise 1 has a little information that we haven't studied yet in class. So I need to give you a little bit of background. They give you an equation, and they mentioned this is a circle whose equation is given by this. This is what we haven't studied yet. So what you need to know is that for the equation of a circle, if the center is at the origin on a graph, the equation of the circle will always take this form. It's going to be x squared plus y squared, but it is equal to the radius of the circle. So that's going to be r squared. Remember, r is the radius of the circle. And we'll study more about this a little later. That looks a lot like the Pythagorean theorem, right? And it's because it comes from the Pythagorean theorem, you'll just be astounded that the Pythagorean theorem in right triangles is part of circle equations. So that's to come. But the thing to remember is that the radius is the number that you get when you put x squared plus y squared together. You get the radius squared. So what does that mean here? That means that the 25 that we see here, that is the radius squared of a circle. So what does that tell us about the radius? Let's set this up as an equation. The radius squared is 25. So that means the radius is going to be the square root of 25, or 5. 5 times 5 is 5, right? So 5 is the radius of our circle. Our job is to figure out what is the circumference of the circle. Now, we have the radius, so I'm going to use my red boxed formula for this one. The circumference of the circle is 2 pi, oh, I forgot my 2, 2 pi times the radius of the circle. Well, we just figured the radius of the circle was 5, so bring that in, plug it in, and when we multiply the 2 with the 5, that's going to be 10 pi. 2 times 5 is 10, and then bring down the pi, 10 pi. All of our decimals, though, are in, all of our answers here are in decimal, so we need to go to the calculator to figure out about what 10 pi is. So let's put its approximation and open up the calculator. We're going to go 10 times pi, or 10 pi. Remember, the pi button is down here by your alpha keys. So 10 times pi, 31.4159. Now we're going to round that, but you can see which one that's closer to. 31.4 about. So our answer choice would be choice 3. Okay, you're going to see one of these on your homework assignment. So pay attention. Remember that the equation of the circle is going to show up with the radius being squared here at the end. So take a peek at that when you do your homework. All right, let's go to exercise 2. Now a tree, there are circles in trees. If you think about cutting a tree down, you're going to see a circle. And that's what this first statement is saying. A tree trunk has a roughly circular cross section. That means we're cutting it down. So a logger uses a tape measure to find that the circumference of the cross section is 6 feet long, which is going to be the best estimate of the diameter. Let me draw a picture of a tree, at least a little kind of sketch of a tree. Here's my tree. The logger is taking a tape measure and wrapping it around the tree in this kind of a circular way. Can you imagine that going around the tree? And that's a 6-foot measurement, 6 feet there. Now we got to get the diameter of this circle, essentially. And I want you to notice all of our answers are in inches, so we're going to have to be careful about that. Okay, so we have 6 feet in diameter. Let me write down that that's equal to the diameter. So because we have the diameter, it's probably going to be wiser to use the formula up here that uses the diameter. That's going to be my formula of choice. So I'm going to make a note that the circumference is pi times the diameter. And making our substitutions, the diameter, oh my gosh, back it up. I am wrong. This wasn't the diameter. 6 feet is the circumference around. Hello? I got to read carefully. The circumference of the cross section is 6 feet. So cross this out. This is circumference. And I'm still going to use this formula, but the 6 feet is going to go in the circumference spot. So 6 is equal to pi times the diameter. Hope I didn't mess you up too much there. You guys might have seen that before. Okay. Divide by pi, and that's going to let us solve for the diameter. So let's show that. We're going to divide on both sides by pi. That'll cancel pi, leaving me the diameter by itself. And in the calculator, let's go get 6 divided by pi. All right, so that's about 1.9. We're going to call that 1.91. About 1.91. What are the units? 1.91. Remember, the circumference was in feet. That means our diameter is in feet. So squeeze that in. We have 1.91 feet. Our question wants to know what it is in inches. So we have one last step to do, and that is to turn these feet units into inches units. I'm going to do that over here on this side. All right, so 1.91 is feet. Now let me multiply that by a conversion factor. You should know that there are 12 inches in a foot. So I'm going to take and multiply that by the 12 inches in 1 foot. That'll let me cancel the feet here. And now I've got 1.91 times 12. That should be my inches. So let me just hit times 12. 22.91 it goes on. About 22.91. So our answer is now in inches. And if we look at our choices, that makes sense. We've got choice 2, about 23 inches approximately. Okay. All right, sorry for that mess up. I should have paid attention a little closer when I wrote down my circumference. Circumference was 6 feet. I got that switched up. Okay, now remember perimeter, because next we're going to look at kind of a real world thing. This is a garden, and truly, if you look around you, you see a lot of rectangular kind of shapes, but often circles will be a part of a shape. So here is a garden that's a combination of a rectangle and a semicircle attached to the end. We're going to put fence around it. So on that fence line, we are going to go around the garden on all the rectangular or the straight line sides. We're not going to go up that dashed line. Notice it says that here. So we're going to stay on the outside of the garden. When we get to this part, though, we're going to have to go around the curve of this semicircle right here. And we want to find out how many feet of fencing are going to be needed for that. So if we think about our fence, we're going to have it in two parts. We're going to have the straight part, which I'm going to just kind of indicate as the rectangular part. And let's go ahead and figure that out right now. That's just adding up some straight sides. So across the top is 17, down the side is 12. Think about what it would be across the bottom. So we're going to match that 17 up there. So I'm going to label it here. So we got three sides, 17 and 12, and another 17, all added up together. That's going to be a total of 46, I believe, 46 feet for the rectangular part. Now, what about that semicircle? Obviously, we're not going to do a whole circle, but let's look at this and break it down. If I had a whole circle, the circumference would be 2 pi times r. I want to use that new formula. It's a little less familiar to you. Okay, so 2 pi times r. What if I had only a semicircle? Well, if you guessed that I would just cut this in half, then you're exactly right. I would cut it in half. It's not the whole circle anymore. It's the semicircle. And the 2's cancel, which is kind of nice. So the semicircle formula is just going to be pi times r. So let's use that in our picture. Pi times r. Pi times, what's our radius here? What would we fill the blank in with? Okay, keep in mind, the radius is from the center, that would be the center of the circle, out to the edge of the circle. I'm going to do it right here. What would this length be? If you're thinking this is 12 here, this should be 12 over here, and this is going to be half of it. So I would say the radius is 6 feet. And that would go into my formula as the radius, pi times the radius, or switching it around, it's 6 pi. Okay, so let's show that over here. Our radius was 6. I'm going to go pi times 6, 6 pi. And I'm going to leave it at that. You might be wanting to pick up your calculator right now, but this isn't my final answer, and I'm not going to round it. This will be easier if I leave it like that and use it in my total fence now. So let's get the total for the fence. That's going to be the rectangular part, which we got up above as 46. Plus, we're going to add in that semicircle part, bring down that 6 pi. This is what I would put in my calculator. So let's get a final answer on this. Alrighty, so 46, and then adding into that 6 pi. We got 64.8. They said to round to the nearest foot. So let's make that 64, bump that up to a 65 since that's 0.8. And let's say it's approximately 65 feet. Awesome. All right. So that's the idea of circumference, just working with the formula. The next part of what I'd like to do is have you turn the page because I want to give you a little bit better understanding about this number pi. And as it indicates, no surprise, the number pi really is a kind of a mystery. It confused mathematicians for centuries, thousands even of years. And it still is a little bit of a mystery. If you really want to understand pi and how that decimal goes forever and ever, you really do need to take calculus. That's a little bit of a ways away for you in terms of you got a few years to go, but I want you to get a little bit of a picture of what's happening. So in exercise 4, what we're looking at is some regular polygons. We have a square, everything's nice and symmetric, a nice regular hexagon. There's our friend, the octagon with the 8 sides, and a decagon, and then a 15gon. Now these ends, these numbers down here, that's just indicating the number of sides. In fact, in all of these, n is equal to the number of sides in the polygon. The number of sides. But in each of these, you should notice that there's this length of 1, and that comes from the center of the polygon out to a vertex. And they just repeat that on each one of those. So, why do we care about these? Well, you should notice what happens to the shape of the polygon if we increase the number of sides. It's pretty boxy at first, even here in these other ones. But as we get to like n is 15 sides, then this begins to take a look that looks a whole lot more like a circle than a polygon. If you guys were standing far away from it and just looked at it, it would look like a circle to you, even though it has straight sides. There's just a lot of them. So as the number of sides increases, what happens to the shape? Well, let's kind of write this down. So as n increases, remember n is the number of sides, then our shape begins to look more like a circle. All right, so if that's true, then what should the perimeter of these polygons approach? If this looks more and more like a circle, well, then this should approach the distance around a circle. If I were to get the perimeter around this one, I would expect it to be about pretty close to the distance around a circle, or the circumference. So as n increases, the perimeter should look more and more like the circumference. The perimeter becomes more and more like the circumference. Okay, so keep in mind that the radius would be the radius of our circle would be 1. So what would the circumference be if we used a radius of 1? Well, the radius goes into the formula 2 pi times r, or 2 pi times, in this case, 1 for the radius. As a decimal, let's look at what 2 pi times 1 is. So 2 pi, that's basically just 2 pi. I'm not going to multiply by the 1. 2 pi is about I'm reading about, let me try again. 6.28319, and it goes on and on forever. Okay, so let's just get the first couple decimals of that. That's about 6.28. Okay, so what are we saying? We're saying that if I just keep adding more and more sides, my polygon starts to look like a circle, and my perimeter starts to get closer and closer to 6.28. Okay, now exercise 5, we're going to do this. We did this in the last lesson, but I'm going to use it as a point to kind of come back to this. So in exercise 5, let's figure out the perimeter of this 10-sided figure. So it's this one up here. We just kind of exploded it bigger. And we're going to figure out the perimeter of this decagon. Now, I expect that this perimeter should be pretty close to 6.28, not exactly, but this looks kind of like a circle. So I would approximate it about 6.28, but we're going to find it exactly. Okay, so just like we did in the last lesson, we have a triangle, one slice of this. Remember, we can think about several slices coming out from the center. They're all identical. We have 10 of them if we count it up. But we're going to take one slice and kind of set it aside here and ask ourselves, what is the measure of this angle here? Here at the center, which translates to this angle here, this entire angle. So you'll recall that we are going to take 360 degrees. That would be all the way around, but we're going to divide it by the number of angles we have, which are 10 in this case. So we're dividing by the 10. That means this is a 36-degree angle. All right, well, that's good to know, because even though we really don't want this angle, we really want this angle, which is going to be in our right triangle. How big would this angle then be? Well, remember, that's going to be 36 divided by 2, because we're going to take half of this. So really, this angle is 18 degrees, and that's the one we're going to use. Okay, so let's look at just that right triangle. Let me redraw so I have a good picture of it. Squeeze it in here. Okay, there's our right angle. This is 1 on the hypotenuse. This angle, this will be our angle of perspective up here, 18 degrees. And which side do I want to know? I want to know this length here. Okay, the one here at the bottom. Now remember, the reason I want to know that is because what I'm really going for is the perimeter around this decagon. I need to know this one side right here so that I can just multiply it by 10 and go around. So this is my real question. How long is this side? That's the same as this one. I'm going to use x in my right triangle to figure that out. Okay, so here's our question. Using right triangle trig and SOHCAHTOA, the angle of perspective is 18. X is opposite of that. And 1 is the hypotenuse. So let's use a sine ratio where we're saying that the sine of 18 degrees is equal to x over 1. X was the opposite and 1 is the hypotenuse. Now solve for x. Let's put our cross multiply pants on right here. And that gives me 1 times x and 1 times the sine of 18. So x is just the sine of 18 degrees. That's this side. So what does that mean for my entire length, Rick? Well, I'm just going to double that. So the full side length should be 2 times the sine of 18 degrees. Double the length what we got for x. Okay, let's take that over to our picture. This is 2 times the sine of 18 degrees. All right, now let's take a walk all the way around the polygon. How many of those lengths do we have? Well, we have 10. So the perimeter should be the 10 sides that we have multiplied by the length of each one. So I'm going to say it this way, 10 times 2 sine of 18 degrees. Let me call that 20. 10 times 2 is 20, sine of 18 degrees. Okay, so what did we do? We took the number of sides, that's the 10, number of sides, and this was the length of one side. Okay, well, let's look at what that decimal is. What do we get with 10 times the sine of 18? Oops, mistake. Let me try again. That should have been 20 times the sine of 18. I didn't type it in right. 20 times the sine of 18. I wasn't getting the number I expected to get. Okay, I like that number a lot more. So 6.18. It's about 6.18. Okay, so keep in mind the idea here. Why did I not like the first number I got? How did I know right away that I had a mistake at 3.09? It's because I was expecting a number that was close to 6.28. Remember up here? The more sides we add in, the more circular it looks. So the closer to the circumference of a circle I should get. And if the radius is 1, then it should be about 6.28. This is just a little bit off from that. And the truth is, if I add more sides, I get even closer to 6.28. So I'm going to stop the lesson there. We're not going to go look at exercise 6 and 7. But what do you have to know about this? I expect you guys to know that if you have a polygon, a regular polygon that has lots of sides, lots and lots of sides, then its perimeter can be approximated by the circumference formula. It's close to a circle. So if you use the circle formula, you're getting a pretty good approximation of the perimeter. And that might save you a bunch of work like this. Now, if it's not got a lot of sides, like this square, I wouldn't use a circle to figure out the perimeter of a square. But if it does have a lot of sides, go ahead and approximate it with the circumference formula. Okay, so that's the end of our lesson for now. Your job is just the same as I've told you before. I want you to go into your homework packet now, and I'd like you to try all of the C problems. And if you can figure those C problems out, move on to the B problems and the A problems. Remember, If you get all the C problems, you've earned a C on the assignment. If you get to the C problems and the B problems, it's a B. If you get through all of the problems, including the A problems, that's going to give you an A on the assignment. So you decide what you're going for. Be nice to the sub and work hard. All right. You can text me if you have questions, and I can try to answer them that way. Thanks for being a great class. See ya later.